All right. Okay, it's recorded. Yeah. So welcome back to the NLP course and a couple of reminders, and then we can jump right to the lecture right away. All right. So yep. Another reminder. A1 is due on Thursday. All right, Thursday. So the midnight. So take all your time. And who have already started? Great. Yes, yes. You all should start it now. And if trust me, if you just set aside 10 hours, it should be enough, I think. 12 hours, 15 hours is worth it, right? It's worth it. You will struggle and your brain will try to release all the neurons necessary to solve the problem, right? But once you are able to do it, you will be like him. He only takes 2-3 hours to solve this, right? So and it will slowly get lower and lower and lower, right? The number of hours, right? So yeah, and of course I have to remind that this time I'm very different from my machine learning class. That is, I'm very serious on plagiarism, all right? Because you are no longer first year student, you're struggling. I think you guys know everything about me and what I want. So I'm very serious on plagiarism. If I found that there's a pattern in two people, I would just tell Gan to give 0, all right? And even if we are wrong, we reserve the right, all right? So for example, there's no way these two people will come up with the same name function, exactly capital letters here and underscore exactly here. We write code, we know, right? So even though by luck you have the same name, okay, we give you one chance. But the next function, still the same name, exactly same place of underscore, same spacing. We count 1, 2, 3, 4, 5. You also 1, 2, 3, 4, 5 space. 0 right away, okay? So you have to understand me that grading is useless for me. But I, as a parent, if I'm your parent, I need to be strict to you so that you don't do this kind of thing, which would harm your career, right? So you have to understand me. All right, great. Can you use ChatGPT? You can, but use at your own risk. That is, first, if you truly understand what ChatGPT gives you, you're okay. But you need to know that the more you use ChatGPT, the more you don't learn, right? But people who already know, for example, him, we all sometimes use ChatGPT because we already know the answer. So use ChatGPT to help us is okay. But if you don't know the answer and you use ChatGPT, it harms your learning. You need to understand the two scenarios, right? So that is my verdict. But anyway, enjoy this. Who already finished? Hey, show your hand. At least not the web application, like part 2, part 1, part 2. Oh, great. So maybe let me interview the experience a little bit. So how was it, the assignment?
I think it's not that hard, but not that easy.
Okay, so not that hard, but he wants to give you guys encouragement to say not that easy. Okay, and you? What is your?
Not bad, but it's really confusing.
Okay, really confusing. Okay, great. Okay, so hopefully I think you guys can enjoy it. And now you guys know these two guys finished. You guys can approach them and talk to them, right? Great. And I'm not sure the PDF has provided the YouTube necessary to watch. So definitely make sure you watch some of my videos necessary and play at 2x speed, right? Because I speak very slowly. I'm making sure that handicapped people with listening difficulties can still understand me. So I speak very slowly. But when I watch myself, I check one time, right? I 2x is much smoother, like native speakers, right? So that would be my choice. All right, great. So without further ado, then we go to today's slides, right? There's a typo here, neural network. But anyway, the topic today is language models and recurrent neural networks, right? So what is language models? So language models is not what you think, all right? You may think that, okay, this is a model that can understand language, right? Actually, it's not. It's considered a task, right? It's an NLP task, right? So what is some example of NLP tasks? Like sentiment analysis, right? So that is the one task, right? And last week, we also studied about something like NER, right? In which we tag the entities. We also study about POS tagging, right? And those are called NLP tasks, right? They are something that given this input, the output is this. This is the meaning of task. You understand? It's a schema of input and output, right? So that is the meaning of task. Language model also have is also a task. So what is the task? The task is very simple. It's basically next token generation, right? But it happens that in NLP, no one calls this task next token generation for some reason, right? So we call that a language model, right? So what is the like example, right? So for example, I have Chucky is sitting on his what? Chair, right? Very, very clear, right? And so this is a language model, right? So how do you do? Well, you take all this, send to the neural network, and come up with a probability of all the words in the vocab, right? So for example, if you have 50,000 vocabs and the probability, so you have each of the vocab, like some of the vocab very low, some of the vocab very high, right? And I mean, the highest probability is only like 0.2, right? Because there's so many, right? Or maybe even 0.05, like, because they are dominated by so many, right? Right. And then you can, out of this 50,000, you can take the maximum, right? But that is also not the right way in language model, right? If you always take the maximum, whenever you say this is, and let it generate the next word, it will always give you the same word, right? Because you always ask them to give the highest probability, right? So what is the highest probability word next after this is? This is it, maybe. I think this is probably the highest probability in the world, maybe. Okay, don't believe me, right? So whenever you ask ChatGPT, this is, it will always ask it, right? So you may wonder like, okay, Chucky, how do we actually create a creative, very innovative, creative sentence? Well, very simple. We just, instead of picking the max, we can sample using this distribution, right? Very simple. So for example, if I have a cat, let's say I have only 3 vocabs, 0.2, and a dog, 0.5, and mouse is 0.3, right? If I have this distribution of 3 vocabs, let's say I have only 3 vocabs in the world, and I want to take the word and fill in, maybe if I take the max, it's always dog, right? Right? But I can change my strategy to make my next word generation more creative, right? I can do say, please randomly choose from this list. Mouse. I don't know why mouse, but yeah. Right? So this is a 10 words, right? And then we can say that in Python, we got a function called random.choice, right? Random.choice or random.sample, comma 1, right? Then it would just select one word and fit it in, right? Even though cat has only 2 of them, there's still a chance of cat, right? But it's relatively less than dog. and mouse are only 3. But anyway, by doing like this, we sample from the distribution, we got a more creative sentence, right? So that is also one part that we have to understand during inference, right? Yep, but there are so many details I have left out, and we're going to talk in this today's slide, right? What else I want to talk about? Yep, and of course the network we want to study today is a recurrent neural network, right? So I think I can. Okay, let's not delete anything yet. So recurrent neural network is just a vanilla neural network, right? In which basically you have the input, you get the output, and you reverse, right? This is the recurrent neural, right? But if you guys don't like this picture, then this is simply it's the same. This picture and this picture is the same, right? But actually, this picture is more correct. It shows you that actually the weight are shared, right? Are shared. But here you don't see that the weights are shared, but basically all the weights are shared. But of course, later on, we're going to study LSTM, GRU, right? And later on, we're going to say that recurrent neural network are not useful. We're going to shift to transform or something like that. Right, and this is like the pinnacle of NLP now, right? So those are some like super overview, I would say, in 10 minutes, like a crash course, but actually, I don't think it's enough for you to make anything, right? So yep, I think that is a preview of what we're gonna learn today, and hopefully you guys enjoyed, all right? ChatGPT is a language model, all right? ChatGPT is a language. So yep, for those who are wondering, like, where are we, right? So we finished this, right? Right, and we skip a little bit here, and we basically we are where are we? We are today we are around here, and actually we are doing for L language model. Okay, and where else is actually? You may say that, Chucky, how about the tasks? Actually, code generation, machine translation, yes. Right, chatbot, summarization, open-ended question answering, natural language inference. All of this has a component of language model, right? Because you need to generate the next token anyway, right? Great. So this is the frame of the problem, right? So the student opened it could be books, it could be laptops or whatever, right? So this is a language modeling, right? And this is the formal definition, right? I'm not gonna go over, but you should be very comfortable with this notations, right? In which, sorry, yep. So in which the probability of next token given the previous tokens. And this is the probability of the next token, right? And again, you should be very comfortable to understand that this dash means even, right? So it means that what is the probability of so for example, the probability of a red fox, right, is basically the probability of A multiply with red and given A, multiply with fox given A and red, and the probability of dot given all, right? So this is all the probability that give you this, right? Hopefully that is not so confusing, right? So do you guys understand this? Right, so the whole probability depends on the probability of A itself and the probability that A follows with red, right? And the probability that a red, a fox followed by a red, and the probability of a red fox followed by a dot, right? All of this multiply together, right? But if you put a log, then everything becomes plus, right? So those are formal definitions of how we compute the probability distribution of the next word. The reason why I write this equation is because I'm very afraid that you will think like this, right? This is a cat, right? And you may think that the probability of this is a cat is basically equal to the probability of cat even this is all right. And this is not true, right? This is not true, right? Because yeah, it's partially correct that if we want to know whether cat comes after this is a, right? Then that basically we can written that the probability of cat given this is a, right? But we also need to understand that this is a is also the probability of this is, right? Given actually the probability of A, right? Probability of A given this is, right? And then this guy also is a probability of this given is, right? So all of this needs to be multiplied together to give you the whole probability of this, right? So this is something that you have to understand, all right? You mean the next one? The next one is the probability of is given this, right? So if we already have this, what is the probability of next word being is? If we already have this is, what is the probability of A? Next word. If we have this is A, what is the probability of cat being the next word? If we have everything, what is the probability of this is a cat? Which is this guy multiply with this guy, multiply with this guy. And if we have everything, then we multiply everything. Right? Because we need to multiply because they are all independent, right? So if we multiply all of them, we will get the final probability. Yep. Right. But anyway, if you have a fundamental understanding of this, it will be very nice. But when you actually code, I don't think you actually code this part, right? But it's good to understand this in a very statistical way. All right, anyone has any question? Okay, great. So yeah, language model is super important. This is a language model, obviously. And so today we have only 1.5 hours. So I will quickly talk about the history a little bit and then jump to RNN. Again, a lot of students like to ask why we need to study history when we just use, why you don't just teach transformer in day one? Why you need to teach RNN? I think that is like a very foolish approach to learning, right? If you don't learn the reasoning behind the coming of transformer, you will never appreciate transformer, and you will never know when to go back to the RNN, right? When it's needed. So it's always good to study what is done back then. So n-gram. So what is n-gram? So let me quickly give you a preview, and then the next slide should be easier to understand, right? So for example, Chucky is eating sushi, and what is the future park? Future park during midnight after his lecture, right? And let's say we predict lecture, right? Let's say we want to predict lecture. All right. So if we want to predict the next word, there's a notion of n-gram here, right? That is, if I use only this word to predict this word, it's called 1 gram. All right. So if I ignore everything, okay? I only take his and predict the next word. His, it can be so many things, right? His parent. Then if you use only one word, then you can put parent, right? Right? It makes sense, right? Because his parent, right? So if using 1 gram, then you can predict the next word as parent, for example, right? Of course, you may say, Chucky, can we use 2 gram, right? And of course, no one talk about 2 gram, it's bigram, right? This is called bigram. So if I use after his, what do you think is the good word to be the next? After his, huh? His lunch, okay, right? Maybe if you use bigram, maybe lunch makes sense, right? But you can see, I'm not sure it makes sense or not, right? But the more gram you use, the more it makes sense, right? But there's a limit, right? The more you use, also you use more memory. How about midnight, right? Then this is called trigram, right? Midnight after his event, okay. Dinner, okay, after his dinner. So this guy eat even after his dinner, after sushi, even after his dinner, right? But anyway, so I think you guys can see, right? And there's so many gram, right? Until infinite gram, right? You understand? So this is the idea of n-gram, right? And basically that's it. This is like a quick 1 minute understanding. And basically, if you understand this, you don't need to read a couple of next slide. But of course, if you want to know how to compute, then I show you this, right? So the student opened there, and so how do we actually predict this, right? So we can use a lot of n-gram set idea. So I actually define what is unigram, bigram, trigram, 4-gram, right? And the idea is basically collecting statistics how frequent different n-grams are after this word in this slot, right? So I think I got some example here, right? So let's say that I use in this example, I use n-1 gram, right? What do I mean by n-1 gram? N-1 gram means okay, let's say I use 3 gram here, all right? Let's say I say 3 gram because I use 3 gram here, right? And the way I can do is I can count that this guy happened 1,000 times in my Wikipedia, okay? And then students open their books happens to be 500 times. So the probability that books follow this guy is 0.5, right? And then you also have exams, and this one happens 100 times. So the probability is 0.1, 100 divided by 1,000, right? Then based on this probability, you will know that what will be the next word. Based on this, it should be books, right? It should be books. But again, when I put books there, I'm using maximum strategy, right? Right? I'm using argmax, right? That is, I take the highest probability, right? But if you want your sentence to be diverse, then you want to use distribution sampling, right? Sample, in which you give books five chance, right? Per 1 chance of exam, for example, right? Then you randomly pick, then you get a very interesting sentence. Yep. I think you guys already have in mind, like, then which one should I use in which case, right? argmax should use in translation, right? When you translate English to German, English to French, this word should mean this word, right? There's no other word. So you should not play around with creativity. There's no creativity in translation, right? So in translation, it makes a lot of sense to use argmax. What else in distribution sampling? When you want to generate a poem, a Harry Potter story, you want to generate music, whatever, right? Then, or maybe even ChatGPT, right? When you want to answer some question and you don't want to be so boring, like you always answer with the same patterns, then the distribution sampling is probably the much better way to make your prediction more interesting. All right, so this is done. And yep, this is just an example. I should. Yeah, and yeah, this is just example. So I can also sample this one, even though it's not the highest probability, right? Yeah. So you need to understand that. But and you can see that using this n-gram, this is what I created in the. So this is what I found. The price of gold per ton, what production of shoe lasts and shoe. It's not so good, but it still makes a lot of sense, right? You can see. So n-gram is not so bad, but the only big problem you will actually realize is that is model size, right? Because you need to keep all the probabilities, right, in the world, everything, right, and calculate all of them. That means that basically, if you have so many texts, if you have 1 gram, that is 1 time. If you have 2 gram, you do 1 more time. You have 3 gram, you have to do 1 more time, right? So the amount of effort to do this is tremendous. Right? So this is probably the downside of this n-gram that eventually no one uses. So these are some kind of problems that I want to talk about, and there's some quick fix. So what if students open the W never occur in data, right? That means maybe open the what students don't open. Water, let's say water. You cannot open water, right? Right. But and when you don't have water, then water will never be here, right? Water will never be here. But based on NLP philosophy and basically the scientific world, things, even those 0 probabilities, there's no such thing as that, right? That is, there's no such thing as 0 probability. Even you never see a chicken fly, maybe someday there will be a chicken that can fly, right? Right? So based on this philosophy, it doesn't make sense to make water 0. Understood? So at least you need to put 1. 1, at least 1 time. 1. Because you add 1 to water, you need to add to every word in everything. That is called Laplace smoothing. Okay? So the reason why I teach you this is because this word is a very, very common word in NLP. And I hope when you read medium.com, when you watch YouTube, when you read research papers, when they just casually speak this, you will say, what? Actually, it's just that, right? They just +1. Huh? Can you explain again? Basically, if I have all the probability of all the n-grams, I will always add 1 to everyone. Everyone, even those that never appear to them be the next word here, I will add 1. Yes. So there's a very rare chance there will be that word. Yeah. And also add 1 also helps mathematical stability. Right? Because now you don't have something like division by 0, right? Blah, blah, right? So those also helps a lot. The next problem we may have in n-gram is what if students open there never occur in the corpus? Then, well, we're very simple. We just use, we just reduce the grams and just use open there. And this is called back off. But yeah, the number 3 is even though I fixed these 2 problems. By the way, the reason why I talk about these 2 problems is because even today we are still using this solution. Even we are not using n-gram, they are still very relevant, right? But number 3 is we cannot store all the engram. So because it's expensive, so no one uses engrams, right? Even until today. So that is the idea. Okay, great. So those are the big, very quick history. And what is the time now? Okay, window-based neural network. So now after we have engrams, now people say that, okay, engram sucks because we have to statistically calculate all the engrams, right? Which is not possible, right? Basically, you want to count everything in the world. So it's not possible. Now we come to neural network. And this is also no one uses anymore, okay? No one uses anymore. By the way, I have already coded this on the YouTube. This code is already in my GitHub. You can take a look if you want to understand the basic, like in a very basic level, how do I do a language model using window-based neural net? And the idea is only one slide, right? And let's see, this is proposed in 2000, right, by Bengio. Right? Anyone know Bengio? Who know Bengio here? Oh my goodness. If you don't know Bengio, then you don't know deep learning, right? Okay, you guys go and ask ChatGPT or search Google who is Bengio, right? And you will know who is he, all right? But anyway, there's a typo here, Benio, but actually it should be Bengio, right, in 2000. So for example, I have the students open there and they are all XXXX, right? And so you can imagine that this is like a number, like that. This is the ID, right? For those who already do my assignments, you probably understand what I'm talking right now. If you did not do your assignments, you will also understand what I'm going to talk about. Basically, every word has the ID, right? And I'm not sure what are the ID, okay? So don't say why 99, okay? Basically, I'm just assigning ID, and this could be one. One cannot be. One can be usually unknown or whatever. Right? So this is the ID I gave, right? Right. So these are the ID. And because computers don't know the word, right? So basically, we just create a dictionary that map this ID to this word. And then we convert them to embeddings. All right. So so this 32 becomes some numbers, some 4 numbers. I'm not sure even what are those numbers. -1, 2, 99, 42. Okay. We don't know, right? And we don't care because if we use PyTorch, we just use NN.embeddings, map all these numbers to a size of 4, and then you can get the embeddings, right? So you have everything 4, 4, 4. Why 4? Actually, if I put all, then I cannot draw this picture. But usually the size should be 50, 100, 300. You got what I'm talking about, right? And I use this word E. Oh, I forgot completely one thing I should say very clearly, right? You can see that this E is a small capital, small lowercase, but bold, right? Which actually means a vector, right? But actually, I think I do some mistake here, right? I should not bold here, right? Because they are ID, right? So I will go back and fix this. But this is some notations I teach in machine learning class. And then what do we do? So now you can imagine that you have embedding of, basically you combine all of this into one embedding of with 16 guys, okay, all in one. So you have one vector here. The shape is maybe 16 times 1, something like that, like one vector. And then what do? You take this guy, E, multiply with some W, right? And then plus B1 and apply some activation function, right? And then you will get another vector here. Here, I'm very sure that W is probably 16 times 8, right? So you convert this 16 to, that's why there's 8 balls here, right? So those are just a simple dot product, right? And then, so this is the shape of the W. You don't have to take note of this shape, okay? Later on, there will be some pop-up here. Okay, I just told you, otherwise you will say, oh, what is happening? And then you get H. So we call this 8 balls H. And then finally, we can send this to maybe multiply with a U, right? What is U here? U is basically convert, U could be something like 8 times 1, right? In which it converts these 8 balls into just one number. So you multiply this U with this H, you convert to one number, and you just take a softmax to take the probability of all the words, right? So yep, so I think that's the idea. Oh, wait a minute. I think U is not 8 times 1. U should be 8 times V, right? Right, because we want to convert this 8 ball to V probabilities, right? So that could be the U, right? So very, very simple operations, and it's very, very easy in PyTorch. Now, no, I don't have the example. I don't have the shape. Okay, I think you guys can figure out by yourself, right? I will let you draw this, but let's talk about the problem here. So okay, goodness is no sparsity problem. Sparsity here means that not many zero. So not too many zero, not too many zero, right? And you don't need to store everything, but remaining problem is a fixed window. You need to always fix the window. That means that if your neural network only takes forwards, it always takes forward, right? If you want a new neural network that can predict using 5 words in the front, then you need to create a new neural network. Then you will never have enough, right? Basically, of course, also we are not sharing the weights, so x1 and x2 are multiplied completely with different weights, so there are no relationship between their and students. So those are something to be thought of. Do I really not write any? Okay, great. I did not really write the shape for you guys, so it's not good for learning, right? So here, this guy is basically E. Let me write down here quickly. So E is belonging to a real number of a vector of size 20 times 1, right? And then W, 16 actually. Actually, this is a column vector, so 1 to 16, right? And then W is belong to 16 times 8, right? Which convert to 8 dimension. And E is simply that. And then actually, yep. Give me 1 second. Okay, and then the U is R of 8 times V, right? So those are the shape, and this one is definitely belongs to V2. Because once you convert that, it will become V. V2 should be V. Okay. But for those who are taking note right here, I will go back and add this information for your study, right? Great, and of course H is R of 1 times 8. All right, so those are some information, and I will quickly just say that this is no one used this, right? So I just, that's why I quickly say it, and I don't plan to let you guys code this one. But anyway, it's good that you have a very good basics in neural network. All right, so again, if you want to know the niche and ins and outs of everything here, I already coded here on my GitHub. At least go a little bit, spend 1 minute and look at it, get understanding, okay? Now, for those who just wake up and if you say, oh, what are you talking about? Great, you don't need to understand anything. Everything I talk about in the from here until now, it's just history and no one uses it anymore, right? But all of them are very good. I am very smart because I'm very strong in fundamentals, right? And I also want you guys to be not just say, I only know transformer or pre-trained models, right? Which is not really the good basics, right? So RNN. Here I'm gonna propose a simple RNN language model, and how does it look, right? So you can see that Chucky draw very well because he think it's very important, right? So words are that, and now we have a lot of, can't even see here because the screen is blocking, right? And I have words, and okay. So now you convert into some embedding, very similar, right? Similar, right? But here, Chucky this time draw very nicely how you convert this X to E. Basically, you multiply with some E that can transform this into some vectors. And then finally, it's a little bit complicated, but it's very simple, okay? So you can see that I take the E. First thing you need to take a look is I take the E. Give me 1 second. I take the E and dot product with this guy, right? So this guy, this part is here. But I also need to make sure that I carry the information forward, right? Why? Because I want to create a relationship between the previous word and the next word, right? So how do I do that? Well, I firstly initialize a random H0. How do you initialize? This is your famous question, right? Well, just randomize, right? Put any numbers you want. How many circle? This number of circle is called a hyperparameter called hidden size, right? So decide how many, right? Usually is 128, 256, right? You guys use whatever. Here, my example is only 4, which doesn't make sense, but it's good for drawing, right? So randomly initialize any number, right? And take that number, dot product with something called WH. I should change my color. Right, so H0 and WH dot product together, you get this one. And you can see that H is always T minus 1, right? So when I take the WH, I always take the one that is before it, right? Then what do? I add them all up. When I add them all up, let's ignore B1. B1 is useless, right? I mean, he's very important, okay? But we're not gonna talk about B1 very far. Then when we add them up, it becomes H1. It becomes H1, and H1 is right here, which we are blocked, right? H1 is right here, right? Right. So it's blocked in our screen, right? So those are simple process, right? Then we take this one, WE plus WH H1, right? You get this one. One thing you guys should remember that is in this whole network, there's only one WE. Only one WE. We don't have this WE, WE, WE. Are they all the same? They are all the same. You need to remember that, right? Because this is the main principle of recurrent neural network. That is, when we share the same W, we hope that there's a relationship between X1, X2, X1, X2, and 3, X1, X2, X3, and with 4, right? So by sharing, this is called sharing network. And the reason why I'd like to talk about this idea is because even until 2023, a lot of people are still talking about this philosophy, right? That is, when if you share your network, some information can be, some relationship can be made, right? Also, WH, there's only one WH, okay? There's only one WH. So that is very, very important. And lastly, how do you actually predict? Very, very simple. If you want to predict, you take the last H4, right? H4 is some vector of size, right? Some vector of size, hidden size. Very simple. You just pass to a linear layer. Let's say you just multiply with some W, right? Basically a linear, you're not comfortable with math, you just send to NN.linear, right? Right, and say that I'm not sure what is this hidden size. Let's say 4, and then convert to V, right? Then you have V probabilities of words, right? In which you can sample from, right? That's it. That is how you actually predict the next one. So that is that, right? There are 2 more questions I have that I can further explain this. You may wonder, like, what if I have different lengths? So sometimes I want to use 4 words. Sometimes I want to use 3 words. Sometimes I want to use 5 words, right? How do you do? Very, very easy. There are 2 strategies. One is always use a fixed gram, right? So here I'm using 4 gram, right? Example 4 gram. Correct? So I can use 4 gram, and I say that to teach my neural network, I will always use 4 gram to predict the next guy, right? So I would just shift. My window size is always 4. 4, predict this guy. So for example, if I have, let's say this is a very long sentence, right? I'm lazy to think about sentence, right? A, B, C, D, E, F, G, H, I, J, K, all right? So how do I create an example using this? Well, very simple. I just say my first sample is A, B, C, D. Answer is E, right? So this is X and this is Y. Understand? Then I do the same. The next training example, B, C, D, E, and what? F. Yes. Oh my goodness, why I choose this color, right? Then you understand my point? You by doing that, you have how many training samples? So many, right? So many. Once you have all this training sample, you shuffle them. You should shuffle them. If you don't shuffle them, it's not fun, right? It's not robust. Then you just train, finish, right? And then just teach it that whatever follow B is C, whatever follow C is D, whatever follow D is E, and whatever follow E is F always. So you create this. So that is one approach that you can deal with different lengths. That is, you just force it to create a training sample of fixed length. Another way you can think about is, well, we can do like this: group similar lengths together. Right. So the idea is that for those who you want to use trigram, just group them into one batch. So group them into one batch. Right. So that LSTM or RNN will not say, oh, different lengths, right? As long as in one batch they're in same length, is fine. Then next batch you may use another length, is fine. Right. So those are the way. But usually very difficult to group similar lengths into one batch, right? So usually you use padding, right? And I'm not gonna talk too much right here, but the idea is basically if you want everything to be the same length, you just put 0, 0, 0, right? According to the maximum sentence in that batch, right? But of course, the more I talk, you may get confused. You need to go coding, watch my video, you understand very clearly, right? Otherwise I will confuse you more. What else I should say about this slide? There's so many things I need to say, right? Just one last thing I will not talk too much about this slide. You have to understand that when you're actually learning RNN, you only learn this guy and this guy, correctly? These are the only 2 things you learn, correct? A lot of students like to confuse. You don't learn H. Okay? You don't learn H. You learn W, H, and WE. You don't learn H. Of course, once you multiply with whatever, you get the last H, and you use the last H to feed into linear layer, right? But you actually did not learn H, right? So you only learn WE and WH. So what I'm trying to say is that every batch that you learn, you need to clear this. Every batch, you have to clear this and start again, okay? Start again from scratch, right? And then otherwise it will interfere with your learning, and it will not be good, right? So just make sure that you understand this point. You're learning WH and WE and not learning WH still. Right, great. So those are the things I want to say. If you don't understand everything I talk about, okay, go back to the basic and let's understand this, okay? Yeah, and slowly understand the idea. All right, and yep, so finally you take the H4, pass through some linear layer, and that should be fine. So there's a lot of things I want to say here, but this is my last slide before lunch break, right? Not lunch break, tea break, or whatever break, yeah. So you can process any length input. Yep. So W is shared, so the model size is fixed. Yep, it's sequential. This is a very big problem. You should take note of this. Recurrent computation, is very, very slow. This is the main reason why no one uses LSTM anymore. Because if I want to learn the whole world text and I need to do one by one, it would take years, right? And so this is the biggest problem. That's why no one ever uses recurrent neural network nowadays, okay? And I am saying literally no one do that, right? And also, if I have very long length, this WE will slowly lose information on the back, right? You can imagine that if I have 50 words here to predict the next word, the things in the beginning will be lost because you multiply WE so many times, right? So things in the front will be gone. Those are some things that you have to understand, that that's the reason why no one uses RNN. All right, so I think we should take a good break. I have give you so much information. So see you guys. All right, so I'm back, and just one question I got from your friends, and I will quickly go through my slide, and then I think I can show you some code, and you will be like, wow, if I can do a language model, I can do something like this, and that is what in A2. So a student asked me for A1, what do you need to return for the application? Basically, to make your life easier, so this is what we think. So basically, in your application, you search one word like Harry, then it will return just the vocab in your corpus, okay? So that is something you just need to do. You don't need to crawl all the Wikipedia text. That would take too much resources, okay? So that is just a quick comment on my side. All right, great. So let's come back to the slides. And if you understand this slide, I think you already understand almost everything. So the next couple of slides is not so important. So how do you train? We call this way teacher forcing. Teacher forcing. So what do I mean by teacher forcing? So basically, I say that whenever I have dirt, you should take this one, multiply, take the U, it should predict students. Whenever I feed in the students, it should predict open. Open should be here. Whenever I feed open, it should predict there. And whenever I feed there, it should predict exams. and then I sum all this loss. The loss between y hat 1 and whether y hat 1 is actually students, that is the J1 loss. Whether y hat 2 is actually open is J2 loss. Whether y hat 3 is actually there, that is J3 loss, and actually y4 is exams, and that is J4 loss. You add them all up, that is your total loss, right? So that is called, this is called teacher forcing. Teacher forcing, that is you force the model to predict the next word. But actually, I also want to tell you that if you only teach the model to only train using teacher forcing, you get a very rigid sentence, right? Which is fine. This way of training is fine for code, for translation, right? So code generation is like, it must be that, right? Then you should not change any, it should be rigid, right? And translation is also rigid. ผมไปกินข้าว I go to eat rice. It should not be otherwise, right? It should be always that, right? So teacher forcing is very good for that. But what if you want to train your neural network to be more creative? Let's say I want to write a story about Harry Potter, right? Then I don't want to always use teacher forcing, right? So then how do I do? Well, what I can do is that I can say that use teacher forcing 0.5, right? And then what is the rest? Well, I may say that please come up with whatever word here, right? And then you don't need to calculate that loss, right? And carry forward that word. And using this word to predict the next word, and go forward, and go here, and go here, right? So that is also another way that you can actually train your network. That is, you don't have a very definite way of assigning what are the next word, but you basically train based on the next word, next word, next word, right? So that is also a very possible way of training. Okay, so that is training, and yeah, predict, this is inference. So predicting the next word is simply as simple as just passing the last hidden state to some linear layer and sample them. So I'm just gonna skip here very quickly. So this is just a very nice example I show you. So this is basically like inference, right? So you inference auto-regressively here. Yep. So here I say that during training, you want to append start and end token so that it always know that start predictor and happy predict end. All right. So that's why we have to always append start and end. And the process of actually printing out the output is called decoding. It's called decoding. All right, so I'm not gonna talk too much about that, but this is, I'm just trying to say that RNN is not only LN, right? And for example, if you can, the frightened cat jump, you can also train that dirt must give you determinant. Frightened is, I'm not sure what is JJ, could be adjective. Cat is a noun something, and jump is something verb, right? We can also use RNN to train some other tasks, right? We can also use sentiment analysis, the frightened cat jump, take the last hidden state, put W, you can get the whether it's negative or positive, right? Of course, you can also do a much better way to do sentiment analysis is not only to take the last hidden state because you lost information when you train, you can take everything hidden state, average them or maximum them, then pass this to a linear layer, right? That can also be done, right? In a question answering, you can take this one and also the context, and you can pass through some linear layer, concat them together, pass through some linear layer to predict a sentence, a word true. You don't have to worry about this too much. You will learn this later on, but I just want to raise this. Later on, you guys will study something called sequence to sequence, in which we take the whole RNN and we call this encoder, and we can send it to another whole RNN that can decode sentence for you. By the way, language model is a decoder, all right, because it only generates something, all right. A language model is not an encoder. That is something I want to say. I'm not going to talk too much about this. Basically, this is trying to say that the RNN that we learned in here is called vanilla. Vanilla means not chocolate, but vanilla means that it's classic, all right? But there are many variants of RNN, RSTM, GRU, stack, blah, 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 right? So all of this are basically all RNN. All right, and so these are all the summaries for today, and I will quickly jump to the PyTorch so that you guys can know. I should not have unshare this, but I can quickly go to the GitHub so that you guys know how does it look. So here, if you go to fundamental, you will see window classifier for nerd, right? So you can quickly go and take a look. I'm very proud that I have this, but actually there are two types of people. One type of people who just want to get a good job. They don't care about this, okay. But for those who want to know everything, like basically all the fundamentals, you click here and you can learn something new. But of course, what we are interested is not this fundamental, but what we are interested is go to DL, right? I separate all the folders into classification, sequence to sequence, language model, and mass language model, right? So I believe all the tasks in NLP can be classified into these 4 tasks. So you can click on language model. There's a 2 version I actually coded for you guys using LSTM and using transformer plus beam search, right? This guy is a little bit tough, and I'm not going to talk about that today, but I would just show you the code I created, right? So this is related to your A2. Give me 1 second. So this is related to your A2, right? And what I want you to do in A2 is you can go down here. Let's skip all the boring stuff and let's see what is the final results, right? To keep us motivated. So this is basically what I do, right? So basically I feed in Harry Potter is, right? I feed in Harry Potter is. I'm not sure if the back can see, but I feed in Harry Potter is, and then this is what I get, right? Harry Potter is a member of the OVIC. I'm not sure what is OVIC, but Harry Potter is a reference to the Church of. I don't even know that. You may say, Chucky, why it doesn't speak out something related to Harry Potter? The simple reason is because I did not train using Harry Potter. I trained using some random passage in the internet. So that's why it speaks like something, right? This is very bad, right? Right. So definitely this is very bad, and Harry Potter is probably blazing. But you can see that if you use what I created using LSTM, you can already get a very good result, right? And I think we still have some time, so let's try to quickly take a look. But before that, let me just squeeze this guy in. And I cannot see very properly. Okay, good. I got this one. Yep. So let me just quickly go through the code, and then you guys can understand everything very easily. So this is basically PyTorch. Okay, this is too small at the back. Is it okay? Right, and then I load the Wikipedia text, right, using some Huggingface. And there's a test data set, train data set, validation data set. And I teach you how I actually print the text. And pre-processing, there are only two steps, right? Tokenization and numericalization, right? So here is basically doing some tokenization, right? So you can see a lot of tokenizer. And then, of course, I do some numericalization, right? Turn everything into numbers. And then there's some kind of prepared data. So here is very important. So if I have something called Chucky loves eating at AIT, and in the same corpus, I also have, I really love deep learning. I have 10 words, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And given batch size of 3, then I will get 3. I need to divide this 10 into 3. But here in my language model, I add also EOS, right? Simply so that my model can know when it ends. So in total, 12 words. So if I have batch size of 3, I need to divide into 4, right? So the first batch, the Chucky loves eating at AIT EOS. I love deep learning EOS, right? And so that is what I have. And so this is exactly what I do in this part. And here is just changing into train, validation, and test data. And here is the key part, right? I think you guys, I'm not going to talk about all of this, but the real function is only here. All right. You send the source, you put embeddings, some dropout if you need, take the embedding, put it into LSTM, and take the output, right? Pass it into FC layer, and then you get the prediction, right? So in terms of neural network, it's very, very easy. But what can confuse you is probably this shape, right? So you have to go back and be familiar with this shape. And another part that is could be very difficult is the training. So this part is is very trivial in the beginning, but this is very important. Init hidden, right? So every time I start a new epoch, I always need to reset my hidden, right? So remember what I said, right? Because we don't want to learn this hidden. So we always need to reset this hidden. So that is the idea. And also, if you want your speed to be speed up, you can detach hidden. So because we don't want to learn this hidden, we don't need to put this guy into the gradient map of the PyTorch. So you can always detach this guy out from your gradient computational graph of PyTorch, right? So those are two things I want to talk about in this. Otherwise, it looks very, very similar to what you guys already know. And yeah, the rest is like very, very familiar to all of you. This one, you may never see this one. But basically, it say that if your gradients are bigger than some number, please just cap it to some number. Otherwise, you make the number too big. And this is fair. If your gradient is 1,000, right? I mean, positive number 1,000. It doesn't matter you go 1,000 opposite direction, right? You can just cap it to 100, right? Just cap it to 100. Otherwise, your model go to that direction too much. So that is this is called fixing exploding gradients. And yeah, really nothing. Really nothing. Every time if your loss is worse, if your validation loss is much better, then you save the model. And perplexity is basically a metric to measure language model, which is simply exponential of validation loss. But if loss is low, exponential will be low anyway. So you can think that this is basically a loss anyway. So you can see that my model is slowly going down, but the validation is just very slowly. Yep. So everything is going down very, and of course, I just want to quickly go here. I know you guys are sleepy already. Here, so this is the part that I talk about. When you take maybe you first solve max first, right? So you get the probabilities, right? Here, a lot of people do mistake here. You do argmax, right? Or props. You should not argmax. If you argmax, you only argmax for code generation or translation. But if you want to generate interesting sentence, you should sample. Understand? And to sample is very simple, but just use this function called multinomial. It will sample from them one of them, right? Instead of just taking the word with the highest probability, right? And then you can see that if that prediction word is sample again, right? Then you will always have very interesting sentence. And when do you stop in inference? When you meet an EOS. So that's why I need to put an EOS in my training method so that you know that it always needs to generate that EOS in this case. And so here is basically it. And Harry Potter is. And I will talk about temperatures very soon, maybe in a couple of lectures. But basically, this is the example, right? So in your A2, I will ask you to go copy some of the Harry Potter passage and then train and do better than Chucky, okay? Because Chucky language model sucks, like very bad, right? So yeah, I think that's it for today. Hopefully you guys can do some interesting language model using RSnap, okay? Yes, thank you very much. See you Wednesday. All right.